Alright guys, so here we are on the 4th page for the quarter 3 review test. I know if you've watched the other videos, hopefully you've been trying the page before you watch the video, because when you study, you really want to know what you have remembered and what you can do, and then use the videos as a way to jog your memory kind of thing, okay? So let's start with number 15. Here we're multiplying certain expressions, and we're just going to go ahead. Step 1, we can see maybe we can take out a GCF, greatest common factor. So I'm going to go ahead and factor that. 6 is the biggest number that goes into 6 and 12. So if I take it out, a big mistake a lot of you forget is when you take something out, you don't write it. Nothing disappears in math, right? If we take out a 6, it's got to go somewhere. So it's going to go outside our parentheses. So 6a divided by 6 is just 1a, and 12 divided by 6 is 2. Now, if you distributed this, you get the original. Okay, if we didn't have the 6, a plus 2 is different from 6a plus 12. That's why when we factor, we're not changing anything, we're just making it look different. Right, then we have an a here times a to the 3rd power and a plus 2. Now that we've done that, we can see that there's an a plus 2 here and an a plus 2 there, so they cancel out. And that, again, in math, doesn't mean it disappears. It's just something divided by itself is 1. And when you multiply by 1, you don't need to technically write it down. So that's why we say it cancels out, but it really just turns into the number 1. Which means we're left with 6a to the 3rd over a. And we notice that we have an a to the 3rd divided by a. And that's the same thing as a times a divided by a. So you can cancel that out, and we're left with a squared. Or if you remember the rule, when we divide, you subtract the exponents. The 6 is still there, but now we get a squared, and this is just over 1, which means we don't really need to write it. So we're left with 6a squared, and that is option A actually. Okay. So now we're going to go ahead and look at the second one. The second one, if you want, is, again, process of elimination. We know that the vertical asymptote is at 2. So if the vertical asymptote is at x equals 2, then the factor is x minus 2, which should be the denominator, because vertical asymptotes, you set the denominator equal to 0. So I know the denominator, if it's x minus 2 and I set it equal to 0, we get 2. So I look here, that's an x minus 2. That's not x minus 2. So we can go ahead and eliminate b. That's an x minus 1, so that's out. And then there's an x plus 1. So just finding the vertical asymptote, we just figured out the answer is A. If you didn't cancel it out, we can go ahead and apply the same thing to the horizontal asymptote. The horizontal asymptote is at y equals 1. So if it's 1, it can't be top heavy, because top heavy means there's no vertical asymptote. None of these are top heavy. In fact, all of these are the same. Since they're the same, you need to have the highest degree match on top and bottom, and for the numbers in front to be 1. So it's 1 over 1, which again looks like all of them. So the main factor is the vertical asymptote. So it's A. You could also plug in these options into Desmos or your calculator to see which one matches the picture. Okay, that wasn't too bad, hopefully. Next up, we got number 17. So it says the price per person of renting a bus varies inversely. So I'm going to go ahead and highlight important things. The price per person, I'm going to call that P, varies, equals K, inversely with the number of people riding. I'm going to say number of people to be N. So if I create an equation, that's the price per person varies. Inversely, remember from page 2, means divided by the number of people, N. So that was step 1. Step 2, we keep reading. It costs 19 per person. Remember, per person is P. So that's 19 equals 73 people. Number of people is N. So that's 73, and we don't know K. So step 1 is always going to be to find our K. So if we multiply both sides by 73, we should get 1,387. Oops, 1,387. So now we have P equals 1,387 over N. And we keep reading, because how much will it cost per person? So we don't know P, but we know it's 1,387 for 62 people. So we do that division, and we end up with 22.37, which is going to be option D. All right, now we have another rational function. We're going to go ahead and find everything possible. I usually use domain and range last. Okay. And I'm just going to go ahead and find the asymptotes first. Let's move this. Let's adjust that. Okay. So let's keep looking. Go ahead and try and see if you can do it real quick. No. So we're going to pause and you guys try it real quick. Sorry about that, guys. The cat was actually being a little mischievous. Hopefully you try the next problem. I'm going to go ahead and clear this, and let's do this. Vertical asymptote, set the denominator equal to 0. So x plus 4 equals 0. Solve, we actually end up with -4. Okay. Horizontal asymptote, there's two ways you could do it. You can see that there's a -5 out front, so it's just automatically going to be x minus 5. Or we can go ahead and actually get a common denominator, which will be x plus 4. Multiply both sides. So if we do that, we get 2 over x plus 4 minus 5x plus 20 over x plus 4. And if we distribute the negative, we end up with 10x. Oops. No. What am I doing? That's really weird. Alright, we're going to end up with negative 3x minus 18 over x plus 4. Okay. That actually is going to be beneficial when we find the x-intercept, because the x-intercept, you can either plug it into Desmos, or we can go ahead and take the numerator. So negative 3x minus 18, set it equal to 0, and solve. We end up with x being 18 over 3, which simplifies to 6. So our x-intercept is at 6, 0. The y-intercept, you plug in 0 for all x's. So y is going to be 2 over 0 plus 4 minus 5. So that's 2 over 4 minus 5, which is 1/2 minus 5, which is negative 9/2. So our y-intercept is at 0 and negative 9/2. Okay. So if we wanted to graph it, just get like a nice little general picture. I'll do that down here. We know we have an x-intercept at -4. Horizontal asymptote at -5. Okay. X-intercept is at 6. And y-intercept is at negative 9/2. Somewhere here. So if we wanted to, I think I messed up somewhere. Oops, yep. This is actually negative 18/3, which is -6. So that means our x-intercept is here, and our y-intercept is negative 9/2, which is about -4 point something. So here. No, it's not. We're all over the place. And by we, I mean me. 9/2 is about 4.5. So we can graph it. We'll get a picture. End behavior is as x approaches infinity, f of x goes to your horizontal asymptote. And same thing as x approaches negative infinity, f of x approaches -5 as well. That's really hard ink for you guys to see, isn't it? Which is fine. We're just going to work with it. All right. Next, we're going to do domain. Domain always goes with the vertical asymptotes, and we have no holes. The domain goes from negative infinity to our vertical asymptote. Union, you always start back with the same number you ended, and there's no other vertical asymptote, there's no holes, which means we just go straight to infinity. Okay. The range goes hand in hand with the horizontal asymptote and holes. So we start from negative infinity, we work our way to the horizontal asymptote, union, start back with the same number, and then there's no hole or anything else, which means we're going to go straight to infinity. And there it is. If you wanted to, we could have graphed this onto Desmos and seen a picture, but you really don't need the picture. You just need this information to help you guys out. All right, go ahead, try the very next page, and then go ahead and watch the next video. All right, have a great day.